The last formation of the balanced delta Y connection. The balanced delta Y system consists of balanced delta connected source and feeding a balanced Y connected load. That means delta on the generator and Y on the load section. In that particular concept, we will have to go through to the phase voltage in a delta connection. That means phase voltage is equal to the line voltage. That is pretty much similar point of view in the delta generator point. As you can see here, VAB, VB 0 degree, and VBC, VP minus 120 and VP plus 120. These are also the line voltages as well as the phase voltage. Here is VP is equal to VL. No other things will get through this. Again, we can obtain the line currents in many ways. One way is to apply KVL to loop A and BA in 12.18 to get this and to find out the line currents. Okay, how we could find these things? Now get back to the pictorial representation of delta Y connection. Here you can see VL and PP are similar. Phase voltage and line voltages are similar, but the uh, loads are different. The line currents and the phase current are also equal, as you can see here. IB similar to the phase current, IA similar to the load current, but the line voltage is different. So if you want to find out, you have to give the similar equations here. The current hasn't been divided into two parts, but as you know, the difference between the line current IA minus IB, you get this phase current. Okay, there are two currents, IA and IB. There are two incoming currents and one outgoing current in two phases. That means IA minus IB, IA minus IB. Then you find the difference between two currents in every sequence will be this. That leads 30 degree, and that is root 3 times to the line current. Okay. Subsequently, the equations coming forward, we have to go to the previous equation. That what is this that we want to find out? That is, we can obtain the currents, line currents, in many ways. One way is to apply the Kirchhoff's voltage law into certain loop. In what loop? In this loop. In this loop, they apply the Kirchhoff's current law, Kirchhoff's voltage law, to find out the currents. And then these equation forms Vp divided by root 3 minus 30 degree and Zy. You can get the IA line current from this equation. And similarly, the IB will be minus 120, IC will be plus 120 if it is positive sequence. So that is going to be the factor. Other thing is that the equivalent Y connected source, the phase voltages are this: Vp divided by root 3, Vp divided by root 3, Vp divided by root 3, and minus 30 degree. That means each phase voltage of the equivalent Y connected source by dividing the corresponding line voltage of the delta connected source by root 3 and shifting its phase by minus 30 degree. That is, the equivalent Y connected source has the phase voltage. That means if we just convert the delta connection to the Y connection, that means to the phase voltage to the line voltage to the phase voltage, we can also apply this equation similarly, means vice versa. So now that is going to be in similar fashion. We will get phase voltages. That is the chart that you should keep on your mind. Table 12.1. Make a snapshot or get the page number 516 or 539 in your book. You can get all connections and their equivalent equations to solve the maths. That's the example 12.5, that is Y balanced Y connected load with the phase this supplied balanced positive sequence delta connected source with a line voltage 210 volt. Calculate phase current, use VAB as a reference. ZY, this is the ZY. VAB, that's the source voltage, and after VAB divided by root 3, that is VP, that's a VL divided by root 3, you can get VP. They want to find out the phase current, so first of all find out the phase voltages. After finding out the phase voltage, you can also find out